So you are asking me this homework question that you have a normal distribution with a mean of 5.6 inches and a standard deviation of 0.8 inches. So that states that your normal distribution has mean right here of 5.6 inches. And actually, first let's just do it according to standard information. And standard information is this, that for a normal distribution, approximately 68% of the observations are within one standard deviation of the mean. So that means that you will expect it to be between, this is the mean, we subtract one standard deviation, and that will be how much? That will be 4.4 inches, right? So that will be my lower bound, right? Okay, so that's 4.4 inches. And then my upper bound would be 5.6 plus 0.8, that is 6.2 inches. Okay. All right. So this is from the standard information. But to say, say we want more accurate information, so what we would do is this. We can go to our calculator. Here is RTI-84 calculator. Okay. Let me just, I think this is what you are using. So one moment. Let me bring that up here for you. Okay, so what you will do is you'll go to second distribution, go to, I'm going to go to inverse norm. I'm going to go to inverse norm because I know that the middle area is 68%. So if the middle area is 68%, then, sorry. So, I mean, we can answer it directly from from our calculators, but the trouble is that some of your calculators are a little older, and I can't get the middle. I'm sorry. Here we go. So you want the middle 68%. So that means what? Right here, the remainder would be how many percent? 32%, right? So this would be 16%, and this tail is 16%. Which as number translates to 0.16 and 0.68. Okay, so what you can do is go to inverse norm and find the numbers corresponding to 0.16 area to the left, and then this total, that means 0.16 plus, sorry about the handwriting, 0.68, that is 0.84 to the left. Okay, and that will give you the answer. So let's just quickly do that. So I'm going to go to inverse norm. Okay, and then on the left I want my area to be 0.16. Sorry about that. Okay, go to second distribution, inverse norm. Okay, so I want 0.16 as area to the left. Okay, and then 5.6 as the mean, and the standard deviation is 0.8. So that gives me how much? About 4.804. And so you could see that I made like a calculation error here when I was doing it in my head. I did the subtraction incorrect. Okay, so that's 4.8 inches approximately. And then when I go to the second part, here what I'm going to do is this. Now this area changes to, if you remember, if we add these together, I hope I added these together. So this is 0.84, all right. And so that will be about 6.4, and it's so embarrassing, okay, that I made an addition mistake here as well. All right, so it's about 6.4 inches, okay. And now what they are going to, they are asking is this, that if we draw samples of size 62 from this 52 from this population. That is n equals how much? 52. Okay. Then again, it's the same question they're asking, just slightly in a different way. So now the distribution is going to change, as you know. That is because since we are looking at the distribution of sample means of size 52, it will be more consistent. So the standard deviation will change to how much? 0.8 over square root of 52. Okay. So that is because what happens, as we said, that this spread will be narrower now. So this distribution of sample means will have a lesser spread. And as you saw, it's 0.8 over square root of 52. So all that we have to do now is that just go to the calculator and we have to answer the same question. So we'll answer it with the same percentiles. So let me get to the values. Let me go to inverse norm again. I'm not able to recall it well. So it went over there. That's no big deal. 0.6, and I did the same thing, didn't I? Sorry. Second was inverse norm, right? And this is 0.16. Mu is 5.6. And what is the standard deviation now? We could have done that through second enter, but I don't know, when I get in hurry, for some reason it just doesn't work well. And as I said, we could have used this center feature, but we are doing this, using this because many of your calculators doesn't have that feature. So what happens now is that you can see in this red case, it becomes in a much narrower area. That is, this lower end point is what? That is 5.49 inches approximately. So this is 5.49 inches. So that's what the answer would be here. Or you could have gone by that, just 97% rule, but this is more general. And when you go to the other side, what you can do is just say second enter. Now, as we did before, okay, so then we have, we'll just put 0.84, and that will give us 5.71 as this right end point, right? So this is 5.71, and again, even by that rule, 68, 95, 99.7% rule, you'll get the same answer. Okay. Now, say you were using a stat key instead of this. So you'll click on the normal distribution in a stat key and edit the parameters to what? You have 5.6 for the mean, 0.8 for the standard deviation. So here we are, and we want a two-tailed distribution. So it gives us for 0.95. You can change it to 0.68 or whatever you need. You get your answer, 4.8 inches to 6.4 inches. All right. And in case you have this, or otherwise you can just change the standard deviation here when you're looking at the distribution of sample means, and it'll give you the answer directly. Okay. So here you have a survey, your second question, in which you find out that people throw about 11% of what they buy at grocery store away. And what they are saying is that assume that this is the true proportion of such things. That means P is how much? 0.11. The population proportion is 0.11. Let me enlarge it. Okay. All right, 0.11. Okay. And so, and then doing this, if the population proportion is 0.11 and you select a simple random sample of 72 grocery shoppers and want to see their behavior, then they're saying what is the probability that the sample proportion would be 0.07 to how much? 0.081. And that in, like, let me just write that in the terms that you are used to, that is p hat. The sample proportion is going to be between 0.07 to 0.081. Now, you know this, that first of all, let's see this here, that 0.11 times 72, this number will be greater than 5. I'm not calculating it. You don't have to calculate it either. And if I do this, 1 minus 0.11 times 72, that's going to be greater than 5 as well. So according to your textbook's criteria, we can assume that the p hat has a normal distribution. Okay. So we have p hat as approximately a normal distribution with mean at 0.11. And what do we need is that what is the probability that the sample proportion is between 0.07, here is 0.07 to 0.081. Okay, so which we may take it, well, let's just assume that that's here. So we have to answer this question, that what this proportion is going to be, and which will be, again, we can just go to our calculator, and that will be pretty straightforward. What we will do is that we will go to normal CDF. Our lower limit is how much? 0.07. Our upper limit is 0.081. Our mean is 0.11 and standard deviation is, I'm just going to type it as it is, 1 minus 0.11, then divided by 72, and then we should get the answer. What is the answer? 0.0768 approximately. Okay, so this answer is how much? So this area is 0.0768 approximately. Let's make sure that we get right number. Okay, so looking at that, what we have again is 0.0768. So my memory was not that bad in there. Okay, so that's the answer here, that 7.68% of these 72 will show this behavior, or the probability is 0.0768 that the sample behavior would be like this. Okay.